Right, let's do this one, right? Thank you. So, let's now deal with the various sampling techniques for such. Let's start first with what we call systematic sampling, all right? So, in a systematic sampling, we have different steps in here. So, for example, in this visualization, this is the entire frame, right? The list of individuals in the population, right? So, first of all, the first step that we're gonna do is to get the interval that we're looking for, all right? And in the interval is basically the quotient between how big the population is, that's population size, and how big the sample that we're looking for is. Okay, so for example in here, what's your big N? What's your population size for such? Well, there are 12 members of the population, right? So for example in here, just for the case for this one, let's say your N, you want your N to be what? 3. You want a sample size of 3, right? So with that being said, then your interval will be what? What's 12 divided by 3, guys?
4.
4. Very good, right? So that is your interval, K, 4, right? Once again, if you have a population of 12, just for example, right? Typically, it's 100 and up, right? And if your sample size, the number of respondents that you're looking for to represent the population is 3. Again, typically, it should be 30 and above for you to formulate a conclusion, right? But just for this case of this example, let's just make it 3 for now, okay? So your interval is 4. We're gonna use that one later, right? Next one, step number 2, randomly choose a number. Let's call that seed number, right? And that seed number, let's call it P. And that number should be any number from 1 to 4, right? So any number from 1 to 4. So this is what I'm gonna do. I'm gonna do that one randomly, right? So how do I do this randomly? 1, 2, 3. I'm gonna put in here what? 4, right? Good. So random number from 1 to 4. I got number what? 3, right? Be good. So again, in here, I chose my P to be how much? 3. Again, randomly. My 3 in there might be different from your 3. Again, that's a random number generator. Are we good? Right? So what are your numbers then? Step 3, what are your numbers? You start with P, which is 3. The next one will be what? P plus K, right? So the 3 plus 4, what's that gonna be? 3 plus 4? 7, right? You good? What's the next one? P plus 2K, right? So what's P plus 2K? You double this. 8, right? So 3 plus 8, 11. So how many sample size do you need? 3, right? So randomly or systematic random sampling, we chose numbers what? 3, 7, and 11, right? So there's still a little bit of random sampling that happened, right? In terms of choosing the seed, right? But again, it's different from a simple random, right? Good. Again, we choose the interval, we randomly choose the seed, and those are the 2 considerations for our systematic sampling. Are we good, guys? Get it? Okay. Questions regarding that one? Next one, we got in here our cluster sampling, right? So when you talk about cluster sampling, say in here, we have the entire map of the population, right? There are individuals in color black, there are individuals in color red, and individuals in color green, right? So that's the frame, right? So in short, they're what? Heterogeneous mix of population. Okay? Now what do? We're gonna split them into different regions, right? Different regions, not categories, regions, right? Such that those regions that we're dealing with are heterogeneous in nature, right? What are we talking about? we're talking about clusters like what? City, right? Because in a city, for example, Hickory, right? Well, there are different mix of residents in the city of Hickory. So you cannot say that that's a homogeneous group, right? There are different factors or different individuals happening there. Same with Conover, same with Newton. So with that being said, city, county, district, classroom, building, those are what? Floors in a building, those are what? Heterogeneous clusters, right? Now, what you're gonna do now? Well, you're gonna do simple random sampling here, simple random sampling here, or simple random sampling here. Or, typically, this is what you're gonna do. In this case, let's call this what? Cluster 1, for example. You good? This is what? Cluster 2, right? And this is what? Cluster 3. Good. So we have how many clusters in here? 3 clusters, all right? So in that 3 clusters, what we're gonna do? I'm gonna do random sampling again and put in here what? 1, 2, and 3. Okay, we good? And according to this, I choose cluster 2, right? So according to this one, randomly, I chose among these 3 clusters, I chose cluster, what did it say there?
2.
2, right? So where's that cluster 2? You see this cluster 2? So that means these, all the members of cluster 2, oops, right? You see there are 2 blacks, 1 red, and 1 green, right? That's a heterogeneous group, right? Then that cluster in there would represent the entire population. Are we good? Right? Again, the goal for cluster sampling is the grouping must be heterogeneous. There's no commonalities between them. We good? Like for example, in the entire state of North Carolina, if you cluster our state by counties, right, then you're gonna do simple random sampling on all of those counties and you choose how many counties you need for your sampling, right? And then after that, what do? Choose all the members. If not, do random sampling again on that cluster or those set of clusters that you choose. Are we good? Right?
So for heterogeneous, every single part of the population has to be different. That's what it means.
Every single part of the cluster here must be mixed. All right? They don't have any commonalities or similarities.
Okay.
Are we good? All right, so that's my cluster. Typically, you consider what? Their location, right? Is it by block? Is it by street? Or is it by county? Is it by townships, right? So those are heterogeneous groups. Are we good? Got it. Next one, stratified random sampling. This is also by groups, but how different is the stratified random sampling as compared to cluster? Because this is also grouping, right? But how different is this? Well, in here, we got what? Homogeneous grouping, right? So when you say homogeneous grouping, for example here, this entire set of population was split into 2 homogeneous groups. In short, this group, okay, this strata, all right, or stratum on the right and on the left, they have commonalities, right? For example, here, they're all black. For example, what? Let's say these are all male, for example, okay, right? And say, for example, these are all females, right? So there's a commonality in terms of how you split the group, right? Good. Strata, such as what? Male, female, all right? Or sex or gender, right? Okay. Sometimes sex and gender can be interchanged, you know, right? Okay. What else? Age group, right? Whether right now they call it like what's the group right now? Gen Alpha or something, and then there's the Gen Z, and then there's the millennials. So those are some terms that you can use, or some other terms that you can you know, consider as well. Race or ethnicity or nationality can be a consideration as well. So as long as there's some sort of commonalities between the group, then you do this stratified random sampling. Now, what you do? Females and males, right? So on the male side, how many members of the group are there? Six. Right? On the females, how many on the group are there? Seven, right? So they don't need to be equal in terms of their size, right? How do you split them? However, you always do what again in here? Randomize the selection, right? So for the male, for example in here, let's say your N is say what? 3. Good? Okay. So for the male, what do we do in here? You see this 1, 2, 3? I'm gonna put what? Dot, 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 comma, 6, right? Very good. So for the male, we got what? Number 4, right? What's next? Let me click in here again. Number 3. Our sample size is 3. So we need one more, right? So I'm gonna click on here again. And that's number 2. Again, it just so happened that's 4, 3, 2. But again, it should be randomized, ideally. Good. Now I'm gonna do the same simple random sampling on the part of the female, right? So that's the thing about stratified. You're gonna do simple random sampling on each homogeneous group or each strata. Good. So the same in here. I'm gonna put one again. Once again, random parenthesis. Okay. How many females are there? 7, right? So I'm gonna put in here what? 7. So as you may notice, I cannot use this for the female as well because there are only 6. We need 7 for the female, right? So it gave me what? 4, all right, comma. I'm gonna click in here again. 5, comma. I'm gonna click in here again. 6. We good? Right. So there we go. We got in here the following, right? For the male, how many did I get? 2, 3, and 4. Where are those? 2, 3, and 4. Get it? Okay. And for the female side, 4, 5, and 6. So that's 4, 5, and 6. Also, in some cases, if the discrepancy or the size between males and females are too significant, then you can do it by proportion as well. Are we good? Right? Okay. Any questions? But in here, since this is 6 and 7, they're pretty much similar. So basically, choosing 3 on one side and 3 on the other side would be fine. Are we good? Got it? For stratified random sampling. Last one, by the way, we're just choosing sample sizes that are small, but again, for you to formulate a conclusion, the sample size should be big enough for that conclusion to hold. Good. Again, typically 30 and up will be fine, right? But usually 30 or less, it's not big enough for you to actually generalize your findings, right? So the bigger the sample size is, definitely the better, right? So as you may notice, systematic, cluster, and stratified random sampling always use some sort of randomization, right? However, the last one, this convenience sampling, is not random, right? This is a non-random sampling. So just letting you see what's happening in here. This is the researcher, this is the population. And as you may notice, the researcher in here chose the population or part of the population that are what? In terms of proximity, nearest, right? So with that being said, then it's non-random anymore. You didn't even use the random sampling. And also, as you may notice, this doesn't have any chance at all to be a part of the study, just because of the proximity or convenience for the researcher, right? Or it can also be what some other forms of selection bias, right? On the part of the researcher, right? So if the researcher is the one personally choosing who the respondents is gonna be, then that's gonna be a convenience or non-random sampling, right? And it also has case of what? Voluntary bias, right? So when you say voluntary bias or voluntary response bias, look at, say, a particular product or a particular service. Now look at the comments. Even in social media posts, right? Look at the comments. You would see that the comments are what? Polarizing, right? Either, one, they put a comment because they really felt good. They really felt that they got their money's worth. This is a really good product. That's a really good service. Or maybe I got my money back or something, you know. So you're gonna put it in there, right? Or those are really dissatisfied with the service and the product, telling us that what? It's a really terrible service ever in my life, you know. I'm never gonna use this product anymore, etc., etc., right? So that's what we call voluntary response bias. Because typically, for consumers like us, we need to be what? Usually need to be motivated to actually put a comment in there, right? And those are what? Well, definitely us being involved with like strong emotions either for or against whatever it is. Whether that be post, whether that be product, whether that be service, it's the same thing, right? It should be strong emotion for us to actually put in a comment. And that leads to what? Voluntary response bias. And again, what are you gonna get in there? You're not gonna get average comments, right? Because basically those who are busy with their work, you know, they got their money's worth, they got the product and everything, you know, they're happy with it. The most that they can do is put in 5 stars and that's it, right? But those who would put in comments are those who are like what? Have strong feelings, strong emotions about the product. Are we good? All right. Let us see some examples in here and clarify what they are. For example, number 11. Let's read that number 11. Caroline, let's read number 11, please. Thank you. To estimate.
To estimate the percentage of defects in a recent manufacturing batch, a quality control manager at Intel selects every 8th chip that comes on the assembly, starting with the 3rd until she obtains a sample of 140 chips.
Thank you. All right. So that's what she did. This quality control manager, right? And again, this is called what? Systematic. So how did she choose it? So she said she selects every 8th chip starting with the 3rd, right? So she randomly chose 3. What's next? 3 plus 8? What's that? 11, right? So that's 3 plus 8. What's next?
19.
3 plus 16, right? Double 8, right? Which is what? 19, very good. What's next? 3 plus, so what you gonna do with 8 again? Triple 8, right? 24, so what's that gonna be? 27, and so on, until she reaches how many? 140 chips. Bless you. Are we good? Right? So that's why that is systematic, right? It starts with the 3rd, and then count every 8, right? So 3 plus 8, 3 plus double 8, 3 plus triple 8, 3 plus 4 times 8, 3 times 5 times 8, and so on. Are we good? Until she reaches how much? 140 chips. So again, that is what we call systematic sampling. As you may notice, it was used on a what? Quality control, right? If there are a lot of items in there, and honestly, I mean, those are items, they're not people anyway. So, with that being said, it's just easier to pick items and see how good the quality is before even releasing them. We good? Because honestly, you want to do quality control on a factory or an industry simply because you don't want what? Returns, right? Are we good? Got it? Okay. You don't want replacements, right? You don't want recalls, right? You good? There's a lot of product recalls sometimes as well, right? You don't want low rating on the product, right? So you have to do quality control. We good? Right? Let's read number 12, all right? Venus, let's see, number 12. To determine the
To determine the prevalence of human growth hormone (HGH) used among high school varsity baseball players, the State Athletic Commission randomly selects 50 high schools. All members of the selected high schools' varsity baseball teams are tested for HGH.
Thank you, right? So that is what?
Cluster.
Cluster, right? So you have what? All high school varsity baseball players. And what did they do? They chose out of, say, 100 schools on, say, the state of North Carolina. Out of 100 high schools, they chose 50 high schools randomly, right? And then after that, all members of the baseball varsity on each of those 50 schools will be what? Examined for, what's that again? HGH, which is human growth hormone, right? Are we good? Right? And again, when you talk about schools, they are what? Heterogeneous group. Heterogeneous mix. Are we good, guys? Right? Okay. And the last one, number 16. Let's read number 16 in here. Sydney, let's read number 16. Bless you. Right. A radio station.
A radio station asks its listeners to call in their options regarding to use of U.S. force and
Thank you, right? So again, it tells something about what? To call in their opinion, right? So in short, there's what we call what? What kind of bias in here? Voluntary response bias, right? Because honestly, who's gonna call on that radio station? Well, first, the patrons of that radio station, right? Second, those who have like really strong opinions about whatever this is, peacekeeping mission in the United States. We good? Third, what else? Well, those who have time to actually listen to that radio station and actually call them, right? But for busy people, I'm like, I don't have time for this, right? I mean, I have to work, I have to go to my shift, I have to go to my duty. So there's what we call a what? A voluntary response bias, right? It doesn't give every member of the population equal chance or probability to be a respondent. Are we good? Right? Thank you. Any questions? Any questions?